Good morning, everybody. Let us continue with our section on Green's theorem, section 9.12, Green's theorem. So we had discussed the theorem, or we had stated the theorem, Green's theorem, and we had done a few examples related to that, how to apply Green's theorem while solving the problems. Now in this lecture, what we are going to do is we are going to consider a few more examples, and in these examples we are depicting in the first example, that is in example 4, we are dealing with the case where the Green's theorem is not applicable. So I had stated while discussing the Green's theorem in the first lecture, I had stated it clearly that we should keep in mind one thing, that is the functions p, q, dou p by dou y and dou q by dou x all must be continuous in the given region that is mentioned. Okay, so now we'll move on, or we'll see an example in which Green's theorem is not applicable. The example 4 is as follows, that is, let C be a closed curve which consists of 4 straight lines given by C1, C2, C3, C4. So you can see in figure 9.12.7, C1 is y is equal to minus 2, C2 is x is equal to 2, C3 is y is equal to 2, and C4 is x is equal to minus 2. So altogether we'll get a square shape. Okay, so that is our curve consists of all these curves, all these 4 curves combined together. So C is nothing but C1 union C2 union C3 union C4. So the region will be the shaded portion. So now if we see, if we are asked to find the integral of minus y by x square plus y square dx plus x by x square plus y square dy. So here clearly what is p? P of xy is minus y by x square plus y square, and q of x comma y is x by x square plus y square. So here whenever we have x is equal to 0 and y is equal to 0, this function is not defined, right? So p, q, also if you take dou p by dou y also, we'll have to apply the quotient rule. Again we'll have this term x square plus y square in the denominator. So as long as 0 is a point or origin is contained in our region, these functions, that is p, q, dou p by dou y and dou q by dou x, will not be continuous in the origin. I hope the concept is clear. So we have to make sure that we cannot just apply Green's theorems like that. We just have to confirm that these functions are all continuous in the origin. So actually these functions cannot be properly defined also with the origin in our region. So in this case we cannot evaluate this integral using the Green's theorem. Now next, if you just recall, if we have a circle over here, okay, omitting this origin, that is a region with a hole. We are familiar with this, that is regions containing holes. You know what the hole is. So if we are omitting this 0, 0, Green's theorem can be applicable because the functions are all well defined there, and they are continuous also, right? So the next concept is that regions with holes can also be used, or they can be calculated, or the Green's line integral can be evaluated for regions with holes using Green's theorem. Okay, if you see figure 9.12.8, you can see this is our curve. We have 2 curves, C1 and C2, and both are in counterclockwise direction, and R is the region. So if we have to find the line integral over C, where here C will be the union of C1 and C2. So if we are asked to find the line integral over C, we can consider it as a double integral of 2 cases. So if you see in equation 4, you can see that this integral, double integral, is nothing but integral over C1 p dx plus q dy plus integral over C2 p dx plus q dy. That is, all over integral over C can be considered as the sum of the integral over C1 and sum of the integral over C2. And in C1 and C2, the corresponding p, q, r and all are continuous, means we can easily apply our Green's theorem. So we are again revisiting the previous example, omitting the region. Okay, so here you can see region with a hole. So if you see, we are asked to evaluate the same integral. We are asked to evaluate the same line integral, that is minus y by x square plus y square dx plus x by x square plus y square dy. Here C is nothing but C1 union C2. So C1 is our previous C, that is consisting of four line segments, and C2 is another circle, x square plus y square is equal to 1. So if C1 union C2 is C, then clearly the origin is omitted from this. So this is a region with hole. So and 0, the point 0, 0 is omitted. So clearly the function P and Q are continuous. Also, if we take dou P by dou Y by our quotient rule, we can see that it is y square minus x square by x square plus y square whole square, and dou Q by dou X is again y square minus x square by x square plus y square whole square. So here if we apply, now all these are continuous on the region R. Now here if we apply Green's theorem, what will be the answer? Dou P by dou Y and dou Q by dou X both are same, so the answer will be 0. So the line integral is 0. Okay, so I hope that the concept is clear, but here you have to see one thing. There in our, while explaining the concept of regions with holes, we had considered the region with I think one was clockwise and the other was anti-clockwise. So sorry, I think I had mentioned both are in counterclockwise direction. So here also you can see that one is in the curve C1 is in the counterclockwise direction and C2 is in the clockwise direction, right? So the integral is coming out to be 0. So we have learned that if the line integral along two different directions, opposite directions, the sum will be, they'll cancel out each other, right? So that concept is being applied here. So we have to see the orientation clearly, that is if they are of different orientation. If the answer is 0 also, then don't get confused or worried, the line integral value will be 0, because line integrals in opposite directions, they tend to cancel out each other. Okay, so now in this lecture we had seen an example in which the Green's theorem is not applicable. So keep in mind that the functions P, Q, dou P by dou Y and dou Q by dou X must be continuous, and we had seen that we can apply it if we are considering region with holes also. So in we had seen, and the same example we had seen how we can apply the Green's theorem there, and we had obtained the value to be 0 because both the line integrals were in the opposite direction. So with this we shall wind up today's section. So I hope the concept is clear for you guys. So that's it. Thank you. Stay home and stay safe.